All right, so we're going to go ahead and present our notes on 6.1.2. All right, so we've got the circulatory system. So I'm going to first go ahead and watch our video, make sure I'll have this video up on its own as well in case you can't hear it. So we'll go ahead and
The
play
normal
that.
heart has two sides, a right side and a left side, and four chambers: the top receiving chambers, or atrium, and the lower chambers, which are thick-walled pumping chambers called ventricles. Red blood cell will come from either the superior vena cava or the inferior vena cava and enter into the right atrium. Blood then flows across the tricuspid valve to the right ventricle. The right ventricle then squeezes and injects that blood cell into a vessel called the pulmonary artery. Pulmonary artery splits into two vessels, each going to the lungs. As that red blood cell makes its way through the lung, it returns through the pulmonary veins to the left atrium. That blood is now oxygenated. It's picked up oxygen, then goes across the mitral valve into the left ventricle, which does most of the work in terms of delivery of blood to the body. That blood cell is now ejected into the aorta to some organ or muscle or skin.
All right, so this video, continue to come back to it because that's now what we're going to break down for our notes. All right, so we've got the circulatory system. Well, what is really the circulatory system? It's our highway. It's the transportation of all the things that get to our bodies. So it transports the cells, the antibodies, our nutrients, oxygen, carbon dioxide, metabolic waste, hormones, all of it. It transports everything. So all of the things we've talked about with our antibodies, that's your circulatory system. Think about circulation. It's a circle, right? So it's a loop. All right, so it's moving everything around. So that's our circulatory system. We have two divisions of the circulatory system. We're going to break down today our blood vascular system, which is most of what we think about when we're talking about our circulatory system. We also have the lymphatic system. The lymphatic system, unfortunately, doesn't get its due because it's just very complicated and it's complex. And at our level right now, we don't need to go into the lymphatic system. We'll look a little bit at it in tomorrow's notes, but mainly we'll touch again on it in the beginning of 6.2. So just for now, we have two divisions and we're going to break down the blood vascular division. So in our circulatory system, we have our types of blood vessels. If you guys think about a few that you know of, we definitely know veins, right? And maybe some of us know arteries, and we also have capillaries. So we've got arteries, capillaries, and veins. Those are the three main vessels that we're going to talk about when we're talking about our circulatory system. So again, arteries, capillaries, and veins. And one of the reasons I wrote them in this layer is because your capillaries are your go-betweens, your veins, and your arteries. And we'll learn a little bit about that in a few slides. So we have our arteries. When we hear arteries, I want to think about A and away because the arteries are going to carry blood away from the heart. So A, arteries, away from the heart. They are going to have a thick cell membrane because, so on that vessel wall, because there's so much pressure, they have to have thicker vasculature because if they didn't, that pressure from the heart could rupture and cause bleeding. Now, the arteries are super cool. They're when like you're on the movies and you watch and they're like, oh, I got a gusher. Like the blood just like launches from the person like 20 feet across the room. That's when they've hit an artery, that like boom, boom, because the pressure from the heart is pushing the blood through the arteries. So it has a nice, it has a good pressure, has a good propulsion. So that's why it's, when we talk about arteries being hit, that's very fatal if you don't stop the bleeding from an artery because of that pressure and that force of the blood, of the heart pushing that blood out of the system. That's arteries. Then we've got capillaries. Capillaries, I want you to think of as a mesh network or the communicators. It's almost like the telephone lines. So capillaries is this exchange of information that's happening between the veins and the arteries. So this is the site where everything happens. Like the nutrients are exchanged, waste products. So the arteries bring the oxygen. If I'm flowing out of my heart into the rest of my body with oxygenated blood, the arteries bring the oxygen to the capillaries, and then the capillaries take it and hand it on off to where it needs to go. So the capillaries are your mesh system. If you guys have played that game where you put your hands on top of the other and then like you try to hit each other, right, and you flip your hands over really fast, if you ever look at the back of your hand and you notice all these little itty bitty bruises, that's your capillaries bruising. So it's a site of exchange of nutrients, waste products, so your carbon dioxide, all your different types of elements that are in your body, gases will actually pass through, hormones, any other substances that move between your arteries and veins, and also the extracellular fluid. Extracellular fluid we get more into when we talk about the lymphatic system. Then we have our actual veins. So our veins carry blood toward the heart. So veins, some things that are not here, but you want to make mention or note of in your notes, veins are going to have a lower pressure because they don't have that propulsion from the heart because they're going toward the heart. So veins will have a lower pressure. So that vasculature, that cellular, the wall membrane that makes the vessel or the lumen, Lumen, is thinner. That's also why we go into the veins to draw blood, because it's a thinner vessel wall. And then also that flow is toward the heart, so there's not that much pressure. So I don't have to worry about an animal bleeding out if I hit its vein. So because that flow is slower. All right. So veins carry blood toward the heart. So now I'm going to take this blood vascular system and I'm going to now further separate it out. Okay. So I know my blood circulates in the body, but now how and where does it circulate? We have two types of circulation. We have a systemic circulation or systemic circuit. This is where my blood is flowing from the heart to the body back to the heart, right? So my blood needs to get to everything in my body so that way I stay alive, because I need to get nutrients to my cells that are in my body. So I rely on the systemic circuit to do that. So my heart to my body, back to my heart again. Then we have the pulmonary circulation or the pulmonary circuit. I want us to think of a palm, right? So the palm, and if you look at your palm, it's got all these branches. And then what organ has all these branches? Our lungs do, because they have the bronchi. So your pulmonary circuit is when the blood travels from your heart to your lungs, back to your heart again. So pulmonary, think lungs, and then systemic, think full body system. All right. So important note before we kind of dive into that is our heart is holding our blood. Half of our blood in the heart is oxygenated, the other half is deoxygenated. So the left side of my heart has oxygenated blood and the right side of my heart has deoxygenated blood. We can also say if blood is oxygenated, it's oxygen rich, or we can say on the flip side, if it's deoxygenated blood, that means that it's carbon dioxide rich, which, right, we've gone through and we've done our gas exchange in our cells and we've said, hey, you guys need some oxygen in these little shoes? Okay, cool. Like, here, let me give oxygen to the feet, and feet, let me take away your carbon dioxide. So that's what's going on with that piece. So now we're going to go ahead and we're actually going to color the image. So we're going to color our cardiovascular system, and then we're going to color our pulmonary circuit. Okay. So I'm going to split for that video. We'll do that and then we'll come back.